Hello everyone. Welcome to the Syed School. Today, we will learn about the fundamentals of Ethernet LANs. Ethernet LANs. LAN stands for Local Area Network. It's a network that connects computers and other devices within a limited area, like a home, school, office, or building. Types of LANs. 1. Small office. Home office. This term is used to describe businesses that operate from a home or small office space. It's often associated with entrepreneurs, freelancers, and small business owners. 2. Enterprise LANs are local area networks designed for large organizations, such as corporations, universities, and government agencies. They typically involve a complex infrastructure with multiple interconnected devices. Types of Ethernet ports. SFP ports. SFP stands for Small Form Factor Pluggable. It's a type of modular transceiver used in networking equipment to provide connectivity between the device and the optical fiber cable. SFP modules are hot swappable, meaning they can be inserted or removed without powering down the device. 2. RJ45 ports. RJ45 is the most common type of Ethernet port used to connect devices using UTP copper cables. It's a small, rectangular connector with 8 pins. A switch with fiber ports and Ethernet ports. Fiber ports needs transceiver to be inserted manually. Transceiver has a transmitter and a receiver. Fiber optic connectors. Fiber optic connectors are used to connect fiber optic cables to network devices. There are several types of fiber optic connectors, each with its own characteristics and applications. 1. ST, straight tip. 2. SC, subscriber connector. 3. LC, loose end connector. 4. FC, ferrule connector. 5. MPO, multi-fiber push-on. 6. ESCON. 7. MTRJ, multimode true cable RJ. 8. VF45. RJ45 Ethernet port speeds. RJ45 Ethernet ports can vary in speed, depending on the specific standard they adhere to. Here are some common RJ45 Ethernet port speeds. 10 megabits per second port, the slowest common Ethernet speed, typically used in older networks. 100 megabits per second port, a faster speed, often used in home and small office networks. 1 gigabit, 1000 megabits per second, port, the most common speed for modern Ethernet networks, offering significantly faster data transfer rates. 10 gigabit, 10,000 megabits per second, port, a very high-speed option, often used in data centers and high-performance computing environments. Fiber optic port speeds. Fiber optic ports can support a wide range of speeds, depending on the type of fiber cable used and the transceiver module installed. Here are some common speeds for fiber optic ports. 1 gigabit, 1000 megabits per second, a common speed for multimode fiber optic cables. 10 gigabit, 10,000 megabits per second, a higher speed commonly used for single-mode fiber optic cables and data center applications. 25 gigabit, 25,000 megabits per second, a newer, faster speed becoming more common in data centers and high-performance networks. 40 gigabit, 40,000 megabits per second, a very high-speed option, often used in data centers and specialized applications. 100 gigabit, 100,000 megabits per second, the fastest commercially available fiber optic speed, primarily used in data centers and large-scale networks. How to choose copper cables. Choosing the right cut cable for your network depends on several factors, including the required data transfer speed, distance, and environment. Cat5 supports speeds up to 100 megabits per second. Limited distance coverage. Cat5e supports speeds up to 1 gigabit, 1000 megabits per second. Offers improved performance and longer distance coverage compared to Cat5. Cat6 supports speeds up to 1 gigabit, 1000 megabits per second. Offers enhanced shielding and reduced crosstalk for better signal integrity. Cat6a supports speeds up to 10 gigabit, 10,000 megabits per second. Provides superior performance and longer distance coverage compared to Cat6. Cat7 supports speeds up to 10 gigabit, 10,000 megabits per second. Offers enhanced shielding and reduced crosstalk for maximum signal integrity. How to choose fiber cables. Choosing the right fiber optic cable for your network depends on several factors, including the required data transfer speed, distance, and application. Single-mode fiber supports higher data transfer speeds over longer distances. Ideal for long-haul networks, data centers, and high-performance applications. Typically uses a smaller core diameter than multimode fiber. Multimode fiber supports lower data transfer speeds over shorter distances. Suitable for local area networks, LANs, and campus networks. Typically uses a larger core diameter than single-mode fiber.